Okay, so here we have two log equations to solve, and the methods we'll use for each of these is different. For the first one, you'll notice you have a log expression, two log expressions on the left and none on the right. What you need to do here is, if you can, you want to simplify it, right? Like we do with pretty much anything, simplify. And I know a property for logs that allows me to simplify this, and the property looks something like this. It'll look different in different textbooks, but more or less the log is some base of some number m minus the log base b is what I'll call the base, some number n, is equal to the log base b of the quotient of the two, m over n. Okay, so I'm going to apply that property here. So my base is 2, 3x minus 2 divided by x minus 5. Okay, that's what I'm taking the log of. So let me try and group that together a little bit better, and that's equal to 4. Okay, so we've succeeded in writing a single log property. Now we use our definition of logarithm and how it relates to the exponential to simplify this guy, right? Which will look something like this. If the log base b of x equals y, then that's the same thing as b to the y equals x, which is what we'll apply here to simplify this even further. 2 to the 4 equals 3x minus 2 over x minus 5. Okay, and now from here we have a fairly simple equation that we need to solve. So I'll make some more room here, and I have 2 to the 4, which I know is 16. That's 2 times 2 times 2 times 2, right? So if I want, I can simplify that. One more step, so I'll come up here. That's 16 equals 3x minus 2 over x minus 5. And the next thing I want to do when I have a fraction is multiply both sides by the denominator. So that leaves me with 16 times x minus 5 equal to 3x minus 2. 16x minus 90 equals 3x minus 2. Subtract 3x from both sides. You guys know how to do this at this point, right? If you're watching a log equation video, this is now just a linear equation that we're working with. So 13x, I'm going to go ahead and add 90 to both sides, and that would be what, 88, and then finally divide both sides by 13. Okay, that's my answer. That's an 8. 88 over 13. If I want, I can check that, right? And I'm not going to take time to do that in this video, but you take that number, you put it back in, and you should get the solution. You should get this to be a true statement when you put 88 over 13 in here and in here. Okay. All right. So now the next equation. This one is a bit different than the previous one. I have a log statement on both sides. So the good news is that 5x plus 8 has to be the same as 5x minus 3, right? Or at least if I'm going to get a solution, that has to be true, right? Because you're taking the log base 2 of both sides here, okay? So when I do that, I can just equate the two, right? We have a property that says if you're taking the log of something on one side and taking the log of the same base of something on the other side, then that something has to be the same. All right? And you realize pretty quickly that this doesn't make any sense, that 5x plus 8 can't be the same thing as 5x minus 3. Or you could do the typical algebra step. And then you get an 8 equals negative 3, which doesn't make sense, right? So this would have no solution.